So this is your AWS account. Okay, so within the AWS account, we have a VPC. This is our VPC. The VPC, it's the AWS account. The VPC. So VPC, we have or rather two availability zones. Okay, I will mark it as a different color. Availability zone would be blue. Okay, these are two availability zones. AZ1 has subnet 1. Yeah, AZ2 is subnet 2. So this is our architecture so far, right? Okay, all right. So what we are going to do is we're going to launch a highly available WordPress website. Okay, EC2. WordPress 1. To we are going to put a load balancer spanning across these two availability zones. Application load balancer. Okay, WordPress 1, WordPress 2, and also what we're going to do is we're going to slightly think a little innovatively, right? And we're going to use one WordPress website as a writer website. So this is a writer website, writer node. Okay, this is a writer node. So writer node is used by content or the admin to basically publish content. Okay, and then we're going to have the reader nodes. This is like a reader node. Okay, reader node. Okay, and then what we're going to do is we're also going to deploy an RDS. Okay, an RDS, MySQL, and we're also going to create a multi-AZ RDS. Okay, this is the master. This is a standby. So RDS, as I said last time, you have an ability to have a replication between the master and standby, right? And then that is done by so when you have your this writer node also talks to RDS only. So ALB will send the traffic to ALB will send the traffic to the WordPress web server, application server. Yeah, ALB will send it to. So your reader nodes are behind the ALB, not your writer node. Writer node can be accessed through the IP address. Okay. Plus, apart from that, what we are also going to do is we are going to have create a few more resources. Okay, such as S3 buckets. We're going to have a couple of S3 buckets. Okay, so we're going to have a couple of S3 buckets. What these S3 buckets are: one S3 bucket is used to store the code, WordPress code. The other one will store all the media, right? Images, media. So this is the media bucket. We're going to have two buckets, and we're going to have a CloudFront distribution. Okay, CloudFront distribution in front of the media bucket. Code bucket we don't need, but our images will have to be served from the CloudFront. So we're going to have a CloudFront distribution. We're going to have two S3 buckets. We're going to have RDS. Okay, and yeah, so this will be there. So this will be a application that is happening between primary and secondary. Okay, but both the nodes will talk to the primary RDS master only. Okay, so this is going to be our architecture. Okay, and this is going to be around a auto scaling group. So we're going to have an auto scaling group spanning for EC2 clusters. Yeah, this is our auto scaling group. I will color it differently. Okay, I'm going to use this color for auto scaling group. Auto scaling group. Okay, so that's this yellow orange is going to be our auto scaling group. So whenever there is additional load to my WordPress website, this auto scaling group is going to scale out and scale in. Okay, automatically, and your S3 bucket is going to be looked up by the instances that comes up whenever there is a new code that needs to be updated. S3 buckets will be used, and your images will be uploaded to your S3 bucket. The image contains all of that we upload. All of that is uploaded to the S3 bucket. So that way, the images are not served from the server. The images are served from the S3 bucket, and it goes through CloudFront distribution. Okay, so this is going to be our architecture. Okay, all of you are able to understand this. Okay, so this is what we are going to achieve here. So now this is a highly available architecture because you have two availability zones, AZ1 and AZ2, and you have a load balancer in front of it. And load balancer is distributing the traffic to this, and also your database is also in a highly available mode, multi-AZ. This is called the multi-AZ architecture. The database is in a highly available mode, and you're not tying any dependency to the underlying infrastructure. Okay, you're putting all your code in an S3 bucket, and you're going to download that code whenever you need from the S3 bucket. Okay, and also you're storing all your media files, such as your images, right? So when you create a WordPress website and when you create a blog, when you put an image into it, usually that image is stored within the folder in the Linux instance, correct? But what if that Linux instance goes down, right? Or if it crashes, or you lose it, right? You will also lose those images. So rather, you're going to store all the images in a centralized S3 bucket, and whenever new nodes comes up, it basically pulls those images, and whenever objects are added, it's going to basically copy the objects to the media bucket and WordPress code bucket. Okay, that's so whenever you publish, right? So your publisher is the writer, and whoever is accessing it, right? The end users. Now, end users, this is like end user, right? User. This is your end user. So when your end user comes up, end user is going to access your ALB. Okay, that's your end user. Whereas your content writer, the publisher, which is you know, as a publisher, or if you're creating your own blog site, you're going to access the EC2 instance directly. Okay, you're going to use the EC2 instance directly, and the end users are going to come via the ALB's URL. Publisher will access it using the public IP of this EC2 instance, whereas the end users will come through the ALB's FQDN, the DNS endpoint, and then they would access that to access your website. Okay, and when your publisher publishes content, that also goes to your EC2 buckets. Okay, that's how the architecture is. That also goes to EC2, goes to the S3 buckets. Okay, so this is what we're going to achieve today, right? So this way, it's a very resilient architecture. You're not tying the dependency to any infrastructure component. You're completely decoupling the underlying infrastructure from your application, right? And your even if your application goes down, you have one more node so that your end users will not face any downtime, and the same set of code is available across the board. Okay, so this is the architecture that we're going to do. Let's get started. Okay, I'm going to do it now, right? The next 30-40 minutes, following this documentation that I've created. Okay, this is about 23 pages. So all of you can also, I'll give you this document. You can do it when you get into your breakout session. Okay, and I'm going to give this architecture diagram, also embed this architecture diagram out here, so that you understand how the architecture looks like and how do we go about it from there. Okay, cool. Let's get started. Okay, firstly, log into your EC2 AWS console. Okay, the first step is create two S3 buckets. Go to S3. Okay, I'm going to just empty this for a while.
It should be permanently deleted, sir.
Yes. Yeah, I'm going to delete it permanently. I don't want these. Yeah, because I created this, I wanted to start from beginning. So, okay, so it's deleted. So let me just go back. Okay, what is the first step? First step is to create two buckets with RPL lab -code -URID. Yeah, I'm just giving just a name to it. Okay, to create in Asia Pacific Mumbai. Don't change anything. Just leave all the settings as it is. Just create a bucket. Okay, and then create another bucket. It says RPL media bucket, RPL lab -media Prasanna. Same Mumbai. Just create the bucket. Okay, all right. So we have created two buckets. That's the step one. Okay, so then go to CloudFront. Second step is go to CloudFront, create a new CloudFront distribution and select the origin domain name as the media S3 bucket. Leave all the other settings as default and click on create distribution. Okay, let me go to CloudFront. Okay, I'm going to create a new distribution. Get started. Here you select your S3 bucket, RPL lab media, right? And leave everything as it is. Okay, don't change anything. That's what it says. Leave as default and click on create distribution. Okay, so let it create. It will take a while for it to be created. Okay, all right. Come to the next step. Navigate to the VPC console and create the following security groups. You have to create two security groups, Web DMZ and RDS MySQL. I think I already have them, but I'll just walk you through. But you can just create, use the same name, right? I mean, wherever I've given the names, just use the same name so that you'll be able to follow the instructions clearly. Okay, and you'll not get confused along. Go to security groups. I've already created like two security groups. One is called Web DMZ. This is Web DMZ, which has inbound rules as HTTP port 80 source open to world, HTTP inbound is SSH, keep it open to the world so that you don't have to worry about whitelisting your IP address, finding out your IP address and whitelisting it. That is for web DMZ. Then RDS MySQL, select RDS MySQL and select MySQL Aurora TCP 3306 and give the source as this security group, web DMZ security group. So where out here, if you go here, you know how to do that, how to select it. Just select here the SG hyphen, you will get the security group. Select the web DMZ security group here. I've already done that. Okay. Yeah, so that's what is needed. So that's done. Navigate to RDS console and create a MySQL database. I'm going to go to the RDS console. Let me go to the RDS console. Go to RDS database, click on create database. Okay, and use the standard create. Okay, and I've given screenshots for everything. Okay, and I've also given you what names you should use so that it becomes easy for you. Okay, so select the MySQL and then MySQL community, leave it. Keep the production, select the production. Okay, because we want to create a multi-AZ architecture, right? Dev and test doesn't have multi-AZ. Let's keep production. DB instance identifier is RPL lab one is the identifier that I've given. So let me just select that. Settings is databases, name is master. Oops. Master is RPL lab. Master username is RPL lab. Password is, I've just given password. Simple for now. Just keep it like that. And then instance size, just select this. Burstable instance t2.micro. Just select that. Okay. Disable storage auto scaling, like as usual that we did. Leave the remaining as it is. Instead of storage type, select general purpose. Okay, don't go for provisioned IOPS. Okay, that is something that I forgot to mention. I'm going to mention here. Select storage type as general purpose SSD and not provisioned IOPS because you will be charged. Don't do this. You will be charged. Okay, so don't select provisioned IOPS. Keep general purpose SSD 20 GB. Disable the storage auto scaling. Okay, and then here availability and durability, create a standby instance. Yeah, I've selected general purpose SSD here also. Create a standby instance. Okay, create a standby instance, select that. So then come down to connectivity. Select my VPC, leave it default. Okay, public access, make it no. Security groups, choose existing. Remove the default out here. Okay, in the security groups and use the RDS MySQL security group. Select that. Okay, then come down. Port is 3306. Database authentication is password authentication. Just leave it as it is. Then come expand the additional configurations. Database name, give database name as RPL lab as mentioned here. RPL lab. Leave this default. You can disable the automated backups. Just disable it. Disable enhanced monitoring. We don't need enhanced monitoring. Okay. Maintenance, enable auto miner version, leave that, enable delete protection. You can remove this enable delete protection also. Okay. So now let's quickly go through the settings. Select MySQL community, production, RPL lab one is the name that I've given for my database instance. RPL lab is the username, password is password. Instance size is burstable, t2.micro. General purpose SSD, don't go for provisioned IOPS, you'll be charged. I mean, it's going to be charged. It's going to be charged pretty heavily. Don't go for provisioned IOPS. Please follow these instructions very, very clearly so that you don't end up in a position where you are charged your account and you pay a heavy bill. Okay, so every time Amazon is not going to discount those bills. Okay, once in a while they do it, but yeah, they're not going to do it every time. So rather, it's better to take precautions and take necessary. I mean, you have to concentrate on what you're doing, right? General purpose SSD20, disable the storage auto scaling, create a standby instance, select your VPC, my VPC, subnet group, just leave it default, no public access, choose the RDS MySQL, which was created earlier, the step 2, then give the database name as RPL lab. Yeah, yeah. Just go ahead and create the database. Yeah, let the database get created. Okay, we'll come back. In the meantime, let's go to IAM console and create an IAM role. Fifth step, let's go to IAM. Go to IAM console. Create a new IAM rule as per the below. Select EC2 and attach permission policy as Amazon S3 full access. Because what we want to do is we want our EC2 instances to be able to talk to S3, correct? So yesterday I showed you, yesterday you would have done the lab for IAM role, attaching the IAM role to the EC2 instance. So that's the IAM role that we're going to create so that your EC2 instances will have access to S3 buckets. Yeah, go to roles, create a new role, select EC2 because that is the use case that you want. Click on next permissions. In the permissions, so in the permissions, select type S3 and you will get S3 full access. Click next. Okay. So then click next review, give a name. So just use the same name, right? I mean, I've given S3 for WordPress as the name. So give the same name for the role. I've already created it, but I'm not going to do that again. So just that's present for me already, and then just create the role. So once the role is created, navigate to the EC2 console and provision a new EC2 instance. I'm going to go to EC2 console, provision a new EC2 instance, launch an EC2 instance using Amazon Linux 2 AMI. I've given all the steps out here. Use the Amazon Linux 2 AMI, T2.micro, okay, my VPC subnet 1, which is the public subnet. Okay, and then click next, add storage, same storage, and in the tags, give a name as WordPress golden image. Click secure, configure security group. The security group, select web DMZ as the security group. Select an existing security group, and web DMZ is the security group. Next, review and launch. Use your key pair, RPL Mumbai Lab, launch instances. Okay, so that's done. Let this come up. I'm just going to pull this public IP address. I'm going to let this come up. So once this comes up, what I'm going to do is I'm going to log into that EC2 instance using Putty or SSH and do all of these steps. Okay, perform all of these steps too. This is something that we did already in the RDS lab. Okay, if all of you remember, we have done this in the RDS lab. Okay, so this is running now. I'm going to grab the IP address of this. Go to my terminal. I'm going to log into that EC2 instance. Yeah, I've logged into that EC2 instance. Okay, I'm going to just go ahead and follow these commands. Okay, sudo yum update -y. So it's going to update the EC2. Then I'm going to install HTTPD. HTTPD start. Then I'm going to install additional softwares which is needed for my RDS, MySQL. Then I'm going to download the WordPress latest version. Yeah, it's downloaded. Yeah, so then I'm going to unzip it, go to CD WordPress, okay, then copy, clear the screen and do it from top. Go to cd/home/ec2user, sudo copy -r WordPress to /var www.html. That's done. Then just do a sudo su, then go to cd/var/www.html. Then so you have all the WordPress files here. I'll just clear the screen. I'm going to create a healthcheck.html, okay, for my word load balancer health checks. Yeah, I've just created a simple healthy.html saying healthy, right? Healthy.html. Okay, so then I'm going to do a I'm going to download an object from another S3 bucket called htaccess.txt. Just download that. Okay, that would have downloaded that. So once that is downloaded, then you have to just rename it as .htaccess. Okay, so then check config httpd on so that httpd would start automatically. Then just do a httpd restart. Yeah, you've restarted the httpd. Then you install MySQL client. Yeah, it's already created. Okay. Okay, so now export this MySQL host using your RDS endpoint. What is my RDS endpoint? Let me just go back to my RDS console. Hopefully it's created. Okay, this is my RDS. It's created. It's modifying still, but I'll just grab this and I'll use this here. Okay, that's my RDS instance. I've just exported that variable. Okay, so now let's log into my RDS instance. Okay, so use this MySQL. If you have not changed any of these, you just simply have to copy paste this. Okay, you don't have to do anything else, provided you followed the same naming convention that I have done. Otherwise, if you have changed it, this would fail. You have to change it. Okay, I've logged into my RDS instance. I was able to log into my RDS instance. Once I'm there, let's create a new user called WordPress, identified by password. User ID will be WordPress, password will be password. Okay, then grant all privileges on RPL lab database to WordPress user. Yeah, you've given that. Flush the privileges and exit. Okay, you've exited. Okay, so now you have to edit the WP config in PHP to modify the following lines as usual, right? So now nano WP config .php. Okay, I'm here. I'll just go down. I'll just change the variables here. Database name is, what's the database name? That's RPL lab. Username is WordPress is the username. Password is just password. Okay, and host name is your RDS host name, right? Your RDS endpoint. Again, go to RDS, come back, grab it, paste it. Yeah, it's pasted. Okay, that's done. So then comes here your salt, your secret keys and salts, right? So copy paste this into a browser, or you can just navigate this in a browser. You will get a unique salt. Copy this, go back to your nano, and out here, just going to delete all these lines and paste these lines out here. What happened? something go wrong? Okay, I'm just going to not save this, come back, again, redo this. Delete these, edit and paste. Okay, I think it's okay. All right, let me redo these. My database name is RPL lab WordPress password database hostess. This one, copy, come back, paste it here. Yeah, so that's done. I think we are good. So let me just come out and save it. Okay, that's done. That's saved. Okay, so then execute this, restart the HTTPD once again. Yeah, you've restarted the HTTPD once again. So now you have to edit the HT access in this. Okay, so you'll find HT access lsi-l.ht access. So you find this file. So now nano.ht access. Okay, so out here, what you have to do is you have to go change this endpoint to match your CloudFront's endpoint. Okay, go back to CloudFront. Just go to CloudFront to see if the distribution is ready. Okay, yeah, so the distribution is ready. I'm just going to delete the older one. Just let it go. Okay, so the distribution is ready. Okay, I'm just going to grab this portion from the distribution. This is the endpoint. I'm just going to come here and then delete this portion and then paste it. Yeah, that's basically what it is. Okay, just going to save it. Save. Yeah, just saved. Next is again once again do a restart of your service. Then go to cd/where www.html. You're already there. Okay, so what you need to do is you have this WP content. You have to change the permissions of this content. Okay, I think it doesn't have the right permissions. Okay, so let's give right permissions to this WP content. So chmod triple server WP content. Yeah. Yeah, so now WP content has got right permissions as well, full permissions. Okay, so now navigate to the EC2 console. Okay, so you have your EC2 instance which is running the WordPress golden image. Select that, go to actions, click on security, modify the IAM role for that. Okay, so modify the IAM role and use the S3 for WordPress role here. Okay, S3 for WordPress. Use that role, attach that role to the EC2 instance. Okay, that's attached. Okay, so you should be able to see that. Just refresh it, come down. You should be able to see it here. Okay, that's done. Next, type AWS S3 LS in the console in the EC2 instance. Yeah, you should be able to see your buckets. The RPL lab code Prasanna, RPL lab media Prasanna is something that you should be able to see. Okay, we're able to see that. Okay, so now sync the code directory, right? I mean, you have to basically what you have to do is you're uploading. Right now, my S3 buckets are empty, right? I mean, I don't have anything in my S3 buckets. Let me just go to my S3 buckets. Yeah, so I have RPL lab code Prasanna, media Prasanna is empty. There's nothing in here, right? So let's upload the code into the S3 bucket, into the code S3 bucket. Just copy paste this. But you have to change your this thing to Prasanna. or your ID. Okay, RPLab hyphen code hyphen your ID. Okay, so use this AWS. Yeah, AWS S3 sync / where www.html. So it's going to take that entire contents of HTML into my S3 bucket. So just do that. It'll take a while to kind of upload the whole thing into S3. Just wait for a minute or so. Yeah, it's copied over everything. If you go back to your S3 bucket and refresh this, you will see the entire code populated to the S3 bucket. Okay, which we are going to make use of. Okay, that is step 18. Step 19 is, okay, you have to create a, you have to make um, your media bucket, right? Okay, you have to make your media bucket accessible. Okay, so now what we are doing is you're making your media bucket public. Okay, that's what you're trying to do here. So just copy this bucket policy, go back to your S3 console, go back to S3, and then select your media bucket, go to permissions, click on bucket policy, edit bucket policy, and paste this in the bucket policy. But here you have to change the bucket name to match your bucket name. What is your bucket name here? RPL Media, RPL Lab Media Prasanna is the bucket name. So just select that. Okay, so what you're doing is you're allowing all principals to access your media, right? Because you're creating a blog site, correct? So obviously your end user should have access to retrieving content from the S3 bucket, right? So save changes. Okay, so in this case, I mean, my account is a bit restricted, so I cannot do it, but you can do this in your accounts. You can do this. Okay, so but for now, what I'm going to do is I'm going. You can also achieve this using in CloudFront. You have something called uh, origin access identity, where you're only allowing CloudFront to access your S3 bucket, and no one else will be able to access your S3 bucket. So I'm going to do that in my case, but you can follow the document, right? You can just follow the.
Sir, your voice is breaking, sir.
Sorry, is my voice breaking? Okay, one sec.
Sir, can you go a
How's it?
little bit of slow?
Yeah, sure.
Thank you.
Is it okay now? Is my voice okay?
Yeah, now okay, sir.
Okay. So don't worry. I mean, everything is there in the document. Okay, you don't have to worry about it. I mean, everything is there in the document. You will, if you just follow the step-by-step instructions given in the document, you should be able to complete the project. Ignore this step. This step is something which is not needed. Just ignore it. Okay. If any of you would not like to give your S3 bucket as a public, okay, then what you can do is you can just go to CloudFront. CloudFront, I told you last time that there's something called origin access identity, where it's a special user. So where only CloudFront will be able to access your S3 bucket. End users coming from outside won't come directly and access your S3 buckets. They have to cloud through CloudFront. That is what I'm doing here. Okay, so I'm just going to edit it. Okay, so that's done. So if I just go back to my bucket, so just refresh it. Okay, and if you go to media folder, if I go to the media bucket, I should see that it would have automatically put the bucket policy to allow only the CloudFront user to access the bucket. No one else will be able to access the bucket, which is fine. Okay, so that's done. But you can do this step. Okay, don't follow the one that I just showed you, but you can just follow the document because you will be able to create a public bucket. Okay, so then I'm in the step 20. let's create a load balancer. So now what all have we done? Let's take a quick stock of it. We have created this. Sorry. So we have created this. We have created this. Okay, I'll just put a small red dot. This is created. 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 And this is also created. CloudFront distribution is also created. Okay. I mean, we have not created this part. We'll come back to this. But for now, if you see, all these dotted resources are created. Now we are going to create the load balancer, application load balancer. Okay. I'm just going to EC2 console. And in the EC2 console, select the click load balancer. So just follow the steps that is mentioned here. Select application load balancer and give the name as mentioned in the document. Just create a load balancer. Select application load balancer. Create the name provided here. RPL Lab ALB WP. RPL Lab ALB WP. Make it internet facing. Yes, it's internet facing. HTTP port 80. And availability zones, select both your availability zones because that's what our design says, right? It's across both the availability zones. Select both the availability zones. Okay, then click on next, configure security groups. In the security group, what is mentioned here in the security group? Select web DMZ security group. Okay, select web DMZ. Yeah, select web DMZ. Yeah, configure next, configure routing. Okay, so when it comes to configure routing, create a new target group. Yeah, new target group and RPL Lab WPTG. RPL Lab WPTG is the name of my target group. Okay, then make it instance. Okay, so leave everything as it is, no changes. Come down, expand the advanced health check settings. And before that, you have a path. I have given a path as /healthy.html. If you remember, we have an healthy.html. cd/var www.html has gotten healthy.html. If you see, it's going to check whether this is responding or not. Okay, so healthy.html. It can be anything. It can be one of your static pages as well, or it can be anything which gives a response code of 200. Okay, healthy.html, and then override this a little bit. Okay, you can just change this to about 10 seconds interval. You don't need to keep it 30 seconds. And healthy threshold, just make it 2, don't make it 5. Okay, unhealthy threshold, just make it 3. Timeout is 5 seconds, interval is 10 seconds, and this is 200. Change this portion. Next, register targets. Add WordPress golden image EC2 instance to the target group for now. We're just testing it for now. Okay, so yeah, select the WordPress golden image. Add to registered. Click next, review the whole thing, and just create it. Yeah, you should see a success message once it is created. It's just going to come back. It'll take a while for it to be created. Let it create. Okay, then check the target groups to see if the target is registered and healthy. So go to the target groups. You can go to the target groups here. Select the target group. Okay, and then go to the targets. It will be in initial stage, but yeah, just wait for it to turn healthy. So you should see that turning healthy like this. Okay. See, right now what we are doing is we are simply testing our load balancer whether it is working fine or not. But if you see as per our design, the writer, this is the instance that we have just created. It is not part of the load balancer. We will remove it at a later point in time from the load balancer target group. Okay, we will let the auto scaling group automatically join instances to the load balancer. Okay, so we are going to remove that later at a later point in time. For now, we're just testing it. Okay, it's still initializing. Let it initialize. Okay, in the meantime, just go to the EC2 instance, grab the public IP of the EC2 instance. This is the public IP. Open a new browser tab. Navigate to that. Yes, everything, your setup should come like this. Okay, so let's do that setup. Let's just come back. Just see if the target is coming fine. Target is coming fine. Target is coming fine. Let's just give it a minute. Yeah, healthy. See, it has turned healthy now. Okay, so we are good. So we are good. So now let's come back. And we've also created the load balancer now. Just put it here. The load balancer is created. Okay, so now let's come back. Yeah, so if you can just grab your load balancers DNS name from the load balancers, right? This is the load balancers DNS name. Just grab it, come back instead of this IP address. Just put the load balancers DNS name here. Okay, I think the load balancer is still being created, I guess. Is it active? Yeah, it's active. Let's just give it a minute for the DNS propagation to happen. Just give http:// yeah, give http:// okay, in the front. If it doesn't work, I'm going to make a note of it. Yeah. / ALB DNS endpoint. Okay, you should see the website rendering like this. You should see the website rendering like this. But before this, I mean, let's also do a setup of the website. Okay, don't do the setup of the website through the load balancers IP. Do the setup of the website from the EC2 instance. Okay, I think I forgot to mention that. I'll mention it here before the ALB itself. I'll mention it here. Yeah, after the EC2 instance is created, let's do that step. Yeah, we'll do it here before step 20. Okay, configure your newly created WordPress website. Access the website using the public IP of the EC2 instance. Okay. Yeah, I'm just going to give RPL training labs or RPL project. Just say RPL project blog. I'll just say that username is use admin, password is password, confirm use of weak password. That's okay. That's fine. I'm okay with that. And I'll just give my email ID here and then say install WordPress. Yeah, so login, admin, password, login. Yeah, so here comes our website. This is our URL for accessing the writer node, which is the admins node, right? So this is our URL to access our writer node. Okay. So now what is the URL for accessing the ALB? ALB right now, remember this instance is registered to ALB. So what we are going to do is, let's go after this step. Once you complete this, let's just, all these have been done. I'm just going down. Okay, this is also done. You're able to access the website. So now SSH into the WordPress golden image EC2 instance once again. We are back here. I'm just SSH. Yeah. So what you do is sudo nano cron tab, right? Okay. So now I'm going to introduce you something new in Linux called cron. Cron is a scheduler in Linux. Okay. Like how you have a Windows scheduler in your Windows operating system. Similarly, in Linux, you have something called cron. Okay. Cron tab runs schedule jobs. Okay. So now what we're going to do is in our architecture, whenever a publisher publishes a blog and uploads some images to the WordPress, there is a cron job that is going to run, which is a schedule job that's going to run every 1 minute, and it's going to copy all of that and put it in the S3 buckets, into the centralized S3 buckets. Okay. And then your reader nodes are going to read every 1 minute from the S3 buckets and download those content into the reader nodes. So that way, every 1 minute new content is published and they are taken from the S3 buckets and they are put into your EC2 WordPress reader nodes, which is used by the users. Right? Publisher is the writer, all the other users are readers. Okay, that's what we are going to do, right? So what we do is we just go to the EC2 instance, sudo nano cron tab. Oh, sorry, it's not here. So you have to go to first is you have to go to cd/etc. Okay, that is important. So do a cd/etc, then do a sudo nano cron tab. Okay, you will see this. So this is how you define a job in the cron tab, where this is minute, this is hour, this is day of the month, this is month, day of the week, right? I mean, so if you say here 1 in the first column, it means that it has to run for every 1 minute. Okay, so there is a format to run that. You just copy paste this to the end. I'm just copying it to the clipboard, coming to my cron tab, and then pasting it here. Okay, so now what it does is it runs the job every 1 minute. Okay, and it is running it as root user. And what is the command that it is running? It is the command that it is running is AWS S3 sync -delete. -delete is it's going to delete the entire contents. Okay, and it's going to it's going to delete the entire contents in the destination, and it's going to copy everything from this code prasanna to the local. That's what it is going to do. Okay, so now that's what it's going to do. So now what we'll do is let's leave it like this. Okay, so now what we want to do is we want our reader instances, right? This is our reader nodes. Our reader nodes should read from the code bucket every 1 minute. Okay, and then it has to update the log from the S3 bucket every 1 minute, and it has to copy it to this, right? So that's what we are going to do. It is going to run this every 1 minute. It is copying the contents of whatever files that are there in this S3 bucket into /var www.html, and it is also going to do a delete of the destination before it writes. So it will clear the entire destination. It will fetch new content from S3 bucket, updated content, latest updated content from S3 bucket, and it's going to dump it into this. Okay, so that's what we are going to do. So let's do it. Okay, so now that is done. So after that is done, we are going to take an AMI of this EC2 instance. So we have now configured this EC2 instance. Right now, these two are not existing. Okay, These two will come when we create and take an AMI of this EC2 instance. And when we configure it in the auto scaling group, we are going to spin off these two instances through an image. Okay. So now let's go follow this next step. Step 26 is select the EC2 instance. Select the EC2 instance, go to actions, go to images and create an image. Okay, we're going to create an image. So now give a name to the image as per this RPL lab WP read node. RPL lab WP read node. That's the name that I'm giving. Okay, this is the default read node for WordPress. This is the default read node for WordPress. Okay, and then select this no reboot option. Yeah, select this no reboot option. Okay, and then what you do is, so go and create an image. Click on create an image. So if you want to see what's happening, just go to AMIs. Yeah, you'll be able to see that it's creating the image. It'll take a while. It'll take a couple of minutes for the image to be created. So let it create the image. We'll come back to that. So now let's go back to Putty and again open the cron tab once again. So now the image is created. Now we are going to make use of this image to provision our reader nodes. But now writer node, we have to again revert it back. We have to change the direction, correct? Now, whenever publisher publishes some content to the writer node, it has to push that content to S3 bucket. So we have to change the cron tab's direction in such a way that it is the reverse way, right? So now let me go back to my EC2 instance, open the cron tab. What I'm going to do is I'm just going to reverse this direction. Right now, if you see, source is S3, destination is local. We'll change it the other way around. The destination would be S3. I'm going to delete this, come back, and then flip it. Okay, so now the source is local, destination is S3. Okay, so whenever a publisher publishes, it has to go there. So because this is going to be our writer node, correct? This EC2 instance is our writer node. Okay, if you want, you can just change the name to WordPress RPL lab WordPress writer node. Okay, just change that name. I'm going to update the documentation. Navigate to EC2 console. Change the name of to okay. So now it has become the writer node. Change the name of the WordPress golden image because we have already taken an image of it, which we will use. And here, once the cron tab is open, change the cron schedule to swap the source and destination. Ensure you change the bucket name to reflect your bucket name. Okay. So what I've done is I've made the source as local, destination as S3. And also you need to add one more content there, where one more line there, which will copy all your uploads, image uploads to the media directory. So by default in WordPress, all the images get stored in the cd/var HTML cd wp content cd uploads. Okay, so if you see here, this is where all your images get stored in a folder called uploads and year and month. Okay, and day. I think a day will also come. Year, month, and day. Today is 26th, right? So it will be /26. That's how the images will get stored. Okay, but yeah, let's go back. And what we are doing is we are basically taking this entire uploads directory into S3 bucket so that all the images are also in the centralized bucket. Images are not stored in the EC2 instance. So if the EC2 instance should fail, your images also will go along with the EC2 instance, right? Rather, you're storing all the images in the S3 bucket. Okay, so now let's go back to cd/etc, sudo nano cron tab. Yeah, and then what I'm going to do is I'm going to copy this line and paste it here. Okay, and then in your case, you just have to change this to reflect your name or your ID. Okay, so this is done. Let's just, yeah, so this is done. So now what I'm going to do is I'm just going to /var. Let's test whether it is coming properly or not. www html. I'm here. Let me create a new file. Echo. I'll just first sudo su echo hello rpl greater than test.txt. Okay, so now we are running this cron job every 1 minute, right? So you can just wait for a minute. So what would happen is you will see that your S3 bucket will have the code bucket will get the test.txt populated in a while. So let's just wait. Let the cron job run. Let me refresh this. Yeah, see, here you go. Test.txt is populated. So our cron job is working fine. Right? So there's no issue with our cron job. It's working perfectly fine. Okay. All right. So now let's go continue with our next steps. So finally, the cron tab should look like this below. Okay. This is how it should look like. So just validate that. So now let's go back to the ALB target group, and let us deregister the WordPress golden image from that, because that's just a reader, that's just a writer. I don't want that to be behind my load balancer, right? Because as per the architecture, only the reader nodes are behind the load balancer. Writer node is not behind the load balancer. Okay, it is directly accessed using the IP address. Okay, let me go back to load balancer. I'll go to the target groups. We just added it to test the load balancer, right? That's it. I'll just go to the targets. I'll select this target and say deregister. Yeah, it'll drain and it'll deregister in a while. So let's come back to that. Yeah, okay. Then navigate to auto scaling in EC2 console. Now we are going to create the auto scaling groups. Okay, let's navigate to the auto scaling in the EC2 console and click on launch configuration and create a new launch configuration and choose the setting in the screenshots below. Okay, so click on create a new launch configuration. You have to go here, select launch configurations, click on create launch configurations, give the name as RPL lab WP launch config, RPL lab WP launch config. Select the AMI as our RPL lab WP read node. Okay, RPL lab WP read node. That's the AMI that you have to select. Okay, and then select t2.micro. Select the instance type as t2.micro. t2.micro. Yeah, select it and choose. Okay, so then come down. Okay, select the IAM instance profile as S3 for WordPress. Okay, so here you have IAM instance profile, right? Because we want our EC2 instance to be able to talk to S3, correct? So that's where you have to select that IAM instance profile to select this and make it and talk to S3 bucket. So select the IAM instance role as S3 for WordPress. Okay, so then comes what are the other settings? Yeah, expand the advanced details. Okay, come down, expand this advanced details. Leave everything as it is. So here, user data, right? So here, the user data that we are going to put is, what it's going to do is every time it launches a new EC2 instance as part of the auto scaling policy, right? Out here, whenever it launches a new EC2 instance, it downloads the entire code from the S3 bucket. Okay, it downloads the whole code from the S3 bucket, and we don't need to download the media, right? Because actually media will come through CloudFront. Okay, I'll just delete this. This is not valid. The media would come through CloudFront. Okay, so you don't need media because it will come through a CloudFront distribution. Okay, so your reader nodes will point to the CloudFront distribution and then serve the media content, and your WordPress writer node would dump the media, whichever images are created, it will dump it to the media bucket. So, but you need to download the code every time you bring a new EC2 instance. So that is what this code does, right? So where you're first doing an update of the EC2 instance, then what you're doing is you're doing an S3 sync -- delete. Source is code bucket and destination is HTML, the var www HTML. Okay, let's just copy this, come back, paste it here. Okay, paste it here, and then go back, follow the next set of instructions. Yeah, next set of instructions, you can just leave it other default. And when it comes to security groups, yeah, select the security group as WebDMZ. Okay, that is the security group that you have to select, WebDMZ, and choose the key pair as Mumbai key pair, your RPL Mumbai lab key pair. Yeah, and check this acknowledge, and click on create launch configuration. Okay, so your launch configuration will be ready in a while. So it is ready. Then go click on auto scaling group. Create an auto scaling group as per the below screenshots. Okay, so now I'm here. Click on create auto scaling group. Give the name as RPL Lab WP ASG. RPL Lab WP ASG. Here, instead of launch template, choose launch configuration. That's what I've mentioned here. Instead of launch template, switch to launch configuration and select RPL Lab WP launch config. Switch to launch config. Here, select the launch config that we just created. So you will see the launch config. Click on next. Select your VPC, which is your VPC, my VPC, and select both the subnets, subnet 1, because you want your EC2 instances to come in any of the subnets, correct? Whichever subnet is available, it will provision that in that subnet, in that availability zone. Okay, so you have to select both the subnets because your auto scaling group is spanning both the availability zones. Okay, select both the subnets and then go back, click next. In the load balancer, you have to say attach to an existing load balancer. Select this option, attach to an existing load balancer. And once you ask, then it's going to ask you choose for an application or network load balancer target group. So select the target group as RPL Lab WPTG. RPL Lab WPTG. Select that target group and then click on ELB check, health check type, make it ELB also. You have to check this also. EC2 anyways is there, but you also have a ELB health check. Get that and then come down and then go to the next. Okay, here the desired capacity, follow the steps that are mentioned here, right? Desired is 2, minimum is 1, maximum is 3. Desired is 2. We are going to have 2 instances desired. Minimum is 1, maximum is 3. Okay, do that and then click on next. Okay, here scaling policies. Use select target tracking scaling policy. Select this. Leave everything default. Instead of 300 seconds, make it 60 seconds. Just follow the steps. Okay, so what we are doing is we are tracking policy is average CPU utilization is 50%, and instances need 60 seconds to warm up before including in the metric. Okay, which is giving us 60 seconds. Okay, next, click on next. Skip the notification portion. Skip it. Add tags. You have to add a tag. Add a tag named RPL Lab WP Reader Instance. Add a tag. Give a name. and give RPL lab WP reader instance. Click on next, review the whole thing, right? In the review page, review the whole thing and create the auto scaling group. Just click on create auto scaling group. Okay, so it's creating the auto scaling group. It will take a while. Okay, you can go to the activity tab. I've mentioned that step here. Navigate and check if the new target is registered. If you can also go back, keep the target group open in another tab. You can go to the target group, select the targets, and see if something is getting registered here or not. You will see that in a while, new instances will get registered to the target group, and new EC2 instances will get provisioned. Okay, the reader EC2 instance will get provisioned if you see. Okay, it's already provisioning. See, RPL lab, two instances are being provisioned. See, RPL lab reader instance, 2 instances are getting provisioned because our desired capacity was 2, correct? And then in the target groups, you should see that, oh, okay, two have already come up. See, one has come up in the 1A, the other one has come up in the 1B as per our design. One has come up here, the other one has come up here. It is spread in 2 availability zones. Okay, and both have turned healthy. Okay, both have actually turned healthy. One will have a public IP address, the other one will just have a private IP address because it's in the private subnet. It's not in the public subnet. So that's okay, you don't have to worry about it. Okay, so that's done. Yeah, new targets are registered. So now if you see, review the activity tab in the auto scaling group, you will see that, yeah, I'll just refresh this. Yeah, you will see that capacity got increased from 0 to 2. Okay, the capacity got increased from 0 to 2. Okay, and then what we can do is let it. So now what we are going to do is as a last step. So now website is up and running. Okay, so now we are going to do a few more things. Let's go to the load balancer. Okay, I'm going to grab the load balancer's DNS name. Okay, and then browse the website. Just give http:// yeah, see, website is up and running. Hello world is coming up and everything is coming up. So now what we are going to do is we are going to use our reader instance. Okay, so now as per our design, we're accessing the website through the load balancer's URL, correct? This is the load balancer's URL. We're accessing the website using the load balancer's URL, which is for end users. End users can only read the website, right? They can't write to the website because they don't have access, right? I mean, that's, yeah, so this is just a reader perspective. So now let us access the writer part of it. So this is my writer, this thing, right? So where I'm just hitting HTTP. Whenever you give /WP-admin, it will actually take you to the admin page, which is the writer thing, right? So I've gone here. I think the password was saved. So let me add a new post. Okay, I'm going to add a new post. Let me say add new. Okay, I'll just skip this. I'll just say hello RPL champs. Okay, this is our brand new WordPress blog site with high availability, resiliency, and fault tolerant architecture. Okay, I'm also going to upload some image. Let me just upload an image. I'll just upload it from my local computer. Okay. Let me select some image. Yeah, I'll just upload the AWS logo here. Right? Okay, I'll just say open. Yeah, I've just uploaded it. Let me go ahead and publish this. Okay, I've just published it. Okay, so now in a while, we should actually see it's come here already. So hello, RPL Champs has already come here, right? I mean, when the moment we uploaded it, okay, and it went to the 13, 233, 128, 227, which is my this node. Okay, so once it got uploaded here, the cron job picked it up, it uploaded it to the S3 bucket, and the reader node pulled it from the S3 bucket and brought it here. Okay, so now one more thing that you can observe is, let's right click on this, copy image location. I'll just go here and paste. Okay, there's one more thing that we need to do. Let's do that quickly. So now we want it to come from CloudFront, correct? Let's get it from the CloudFront. So now if you see, this is coming from the local itself. Okay, this is actually coming from the local. Okay, but it has to come from the CloudFront. Okay, in order for it to come from the CloudFront, okay, let's just go here. Let me go back to my writer instance. I'll just go to /var www html. I'll just say sudo su nano.htaccess. Okay, see, this is basically a URL rewrite. Okay, so what it is doing is any content that comes to at a Apache web server level, right? I mean, since WordPress is running in the Apache web server application server, there's something called URL rewrite. So anything that comes with WP content /upload/ anything will get rewritten to this CloudFront URL. Okay, that is what it is doing. Now I'm just going to check whether the CloudFront is up and running. CloudFront has got it. Just give me a second. Okay, CloudFront is deployed. What is the URL here? D13TNSP. Yeah, it's correct. I'll just go to the S3 to see if the so it's actually populated this thing. So this is object actions download open file should have the AWS logo. Yeah, it has the AWS logo. See, it has the AWS logo. So now let me just grab the CloudFront URL and access that /uploads. There's a folder here. Yeah, /2020 right? Yeah, /2020 11 download.png. If I access it using my CloudFront, yeah, it is coming through CloudFront URL also. Okay, so that's coming. Okay, one important step that I forgot to include in the documentation, that is the reason why the URL rewrite is not happening. I'm going to add it right now. Sorry about that. You have to go to cd/where httpd you have to change the configuration once again. Let me just see, where do we change the configuration? cd/where Okay, so it's here /etc cd/etc. I'm going to put it in the document. Don't worry. HTTP conf. Yeah, nano httpd.conf. So here we actually have to have look for one specific configuration which will enable the URL rewrites. Yeah. So allow override has to be all. This is which line number? How do I see the line number? Come out vi httpd. Vi show line numbers. Does this give you colon? Colon set number. Okay. Yeah. Okay. Okay. So you have to go to line number. Yeah, line number 151. Allow override has to be made all. Okay. So once that is done, so then it will be able to actually use this htaccess files and it will be able to redirect it to CloudFront. Okay, I'm going to add that step here. Sorry about that. I'll add it before this. Or in fact, I'll add it here itself. It has to happen before the AMI is taken. So I made a mistake. Yeah, it has to happen here itself. Okay, let's do it here itself. As part of this itself, let's just do it. Let's get the following commands. chmod cd / etc plus httpd /conf. Okay, nano or vi. Okay, anything. Nano sudo nano httpd.conf. Okay, so then navigate to line number 151. Change allow override none to allow override all. So you have to change this key, this only this. Okay, and then save the file and exit. It's important. Series /etc httpd conf, right? /etc httpd conf nano httpd.conf. Okay, to line number 1. Change this none to all. Save the file and exit. Okay, so now what I'm going to do is I'm just going to have to recreate the AMI once again. it's gone. Okay, so but for now what I'm going to do is I'm just going to simply change it in the EC2 instance, log into the EC2 instance and change it. But ensure you don't miss this step, because it's a very important step. Unless you do this, your images won't get redirected to CloudFront through to S3. Okay, that's going to be a challenge. Okay, so I'm just going to do service httpd restart. Yeah, this is done. After that, what I'm going to do is I'm just going to log into the other EC2 instances also. Maybe the primary one. There are 2 EC2 instances running, correct? Just go here, instances. Okay, there are 2 EC2 instances running, reader nodes. I'll just filter by reader instance. Yeah, there are 2 EC2 instances running. Let me first log into the first one. Yeah, so sudo nano /etc httpd conf / httpd.conf. Allow overriders. I'll just make it all. Okay, similarly, let me just change it in the other node as well. This is a private EC2 instance, 10.0.2.50. Just grab my key. Just give me a second. I'm going to stop my screen share. Come grab my key. RTL mobile app.pem. Open with. Okay, that's done. Let me share my screen back. I've copied my key. Okay, just coming here. Oh, sorry, I just copied it here. Okay, so there's an issue there. You see, auto scaling is working its way now. I'm trying to log into the EC2 instance, but it's not allowing me because it has already started terminating it, because I have a CPU utilization, which is preventing me from doing it, correct? Okay, so now let me do one thing. Let me log into my public EC2 instance, and from there, let me go modify it. So there's one node which is running. Okay, so now SSH -I RTL Mumbai. SSH -I. @ let me grab my second node reader instance IP address. Okay, so now if you see one node is terminated, did any of you wonder, is the website still up and running? If I refresh, wait, should it come? Yeah, see, it is still working because the requests are actually going to the second node. If you see, this node is gone down because CPU utilization is low, and it's not able to, it doesn't have to keep it up and running. So it brought the size to minimum 1 instance. So now the second node is running. So there's no outage to the end user, right? I mean, end user is still able to access the website if you see. Okay, so that's the thing. So let me just go here. Sudo nano /etc httpd conf httpd.conf. Okay, I'm just going to go down. Navigate all the way down to allow override to make it all. Just save it. Sudo service httpd restart. Yeah, so it's restarted. So now if you just go and say refresh, I've just refreshed here, so it's still fetching it from there. But if you see the image location now, and copy image location and paste it, it's actually going to the CloudFront. See, it's actually going to the CloudFront's distribution. It's not going elsewhere. It's going to the CloudFront's distribution. Okay. And okay, so now let's do one thing. Let's see the auto scaling work in action. Okay, this is what I wanted to show, that it's actually being rendered from CloudFront. If you open the developer tools and refresh the page, yeah, you will see that the download.png is actually coming from CloudFront. It's actually coming from the CloudFront. See, the download.png AWS is coming from CloudFront's endpoint. It's not coming from your local server. It's coming from CloudFront, and CloudFront is serving the content from S3. So if you see, this is the URL, right? And the CloudFront is serving the content from S3. It's not serving it from your local node. So now if you see, we uploaded the image, and the image would have gone to the reader node 1. But the image is not lost because it is stored in CloudFront. It is stored in S3 bucket. So now the node 1 got terminated. So it did not impact the availability of the images. Even though the node got terminated, it is still available, right? And it's not gone. It's still available. So that is the beauty of creating an architecture which is highly available, right? And you don't lose any data if your infrastructure goes down with due to whatever reason, right? So okay, so now let's do one thing. Now there's only one node which is running, correct? Before that, let me check if I updated the documentation correct. Yes, I've updated the documentation correct. And yes, so this is before. I'm sorry, is my voice audible? It's audible. Okay, cool. Okay, so just follow these steps. I think you should be good. You'll not hit this issue. Okay, and towards the end, I'm just going to add few more steps to the end. Okay, like okay, the site should be accessible. Okay, so now first thing, access the website using the ALB's endpoint. Okay, this should give you, this should take you to the reader nodes, behind the ALB. Okay, then access the website using the public IP address of the writer node, right? What is the writer instance? This is the writer instance, right? So I'll just copy the writer instance. Of the writer node EC2 instance. So like this, it will be like this, access this endpoint. Okay, you have to do it with /wp admin, right? Once logged in to the WP as admin, create a new blog post and upload an image into the same, right? So when you upload an image, let me do one more. Let me do that again. Okay, I'm just going to, this is one. I'll add one more image. I'll add one more. It another blog post. I'm just going to add an image to this. Let me just add an image. Okay, I'll just select this. Okay, this is too large. Let's go to recents. That's I'm just looking for a slightly smaller one. Okay, I'll just use this only. I'll just say open. Yeah. So you will get an error like this. Don't worry about it because it's trying to actually load it from CloudFront, right? So you'll get an error like this. So ignore it. That's okay. Don't worry about it. Ignore if you get an error. The image has an empty alt attribute. Okay, since it's trying to load it from CloudFront endpoint, and it has still not synced, and the image is yet to be synced to the CloudFront. So don't worry, just go publish it. Yeah, it's published. So it's published. Okay, so now if you can just go back to your ALB, right, and then refresh the ALB's endpoint, you should see yet another blog post, and you should see that it has already taken it into CloudFront. You should see that it will load. It's actually loading the images from there. Copy image location, just go here, paste it. Yeah, it should be able to load the image from the CloudFront. Okay, so that's the thing. So okay, that's done. So then what you can do is, let's do some tests. So right now, if you see, okay, now let's do a first test. Once you have, now let me go back to my auto scaling group and make this to original 2 nodes. See, right now the desired capacity has come back to 1, but let me just make the desired capacity to 2. Just update it. Yeah, so let's let it update. It will provision a new EC2 instance and add it. Let's just wait for it to come. You can try all these tests. Play around with the desired capacity and then terminate one instance and try to access your website. You should still be able to access your website. Always remember to access the website using the ALB's URL, not your writer endpoint, writer IP address. So this should get triggered, and this should actually start provisioning an EC2 instance now. Go back to my EC2 console. This got terminated, but it should provision one in its place. Let's just wait for the auto scaling event to get triggered. Yeah, I think right now it's in the cool off period. Just wait for the auto scaling event to be triggered. Just wait for a few minutes. It should trigger the event. And because we changed the capacity, desired capacity to 2, right? It should bring the desired capacity back to 2 in a while. Okay, so this is like test 1. Scenario 1 is test our navigate to terminate a reader instance and browse the site. The site should still be accessible. I'll give you a scenario 2 as well. Okay, scenario 2 is you can log into one of the reader Ec2 instance and bump up the CPU utilization using the script. I'd given that script earlier, right? What was that script? Where is that? Which date was it, if you remember? It's auto scaling, no? So that should be somewhere in. Can somebody ping me that script? The script that I gave last time to bump up the CPU utilization. Do any of you have it handy? I can't find it. It's a for loop. 1, 2, 3, 4,
Sir, I
5.
have sent you in chat, sir.
Okay, cool. Thank you. Yeah, this is what I'm looking at. Okay, I'll just keep it handy. Yeah, this is the one. You can just log into one of those EC2 instances and bump up the CPU utilization using the script. Okay, and then wait for the auto scaling to sense the CPU utilization. Maybe you can run it 2-3 times using the script. Bump up the CPU using the script by running it 2 to 3 times. Wait for the sense the CPU utilization and add a new node to the auto scaling group automatically. Okay. But the best thing is, I mean, just, if you just terminate one instance, it will still be there, because as long as only one instance is there, you'll still be able to access the website. Okay. So let's just wait. I mean, right now, I think it is in a cool off period. You can just wait. Okay. So right now there's only one EC2 instance is running, right? Okay. Let me do one thing. Let me just go and change the Z capacity to actually 1 only. Let it be 1, but the maximum is 3. But let me bump the CPU utilization. Okay. Right now, how many instances are there? Yeah, only one reader instance is there, correct? Yeah, only one reader instance is there. So one is terminated. Okay, so let me just go and do that. Is this the instance which is there? What is the reader instance? 10.02.54. Okay. Yeah, so here. Yeah, let me see top. Yeah, CPU utilization is pretty much nothing. So I'll just run the script. I'll just run a couple. So top, yeah, now it's like hitting 100%, right? So it's 100%. Now let me just go browse my website. You should see that the website will respond a very slow. See, it's responding a bit slow because the CPU utilization is 100%, correct? Yeah, so it's responding a bit slow. So now what we can do is, let's wait and watch the CPU utilization. CloudWatch event should get triggered, and shortly we should see some activity happening in our auto scaling group. Let it be like that for about 3 to 4 minutes. You will see that the auto scaling will trigger, auto scaling will pick up. It's actually 60 seconds, right? So it'll be 60 seconds. Just wait for 60 seconds and come back, and you will see that you can also monitor your CPU utilization here. See, if you see, it's like going up. Okay, so let's wait and watch. I mean, it should just go ahead and, but yeah, it'll work. It'll work. So you can also try it at your end. So let's just wait it for some time. But still, the website is accessible, but it's a bit slow. I mean, it's not as fast as it used to be, because CPU utilization is 100%. Some other processes are actually hogging the CPU utilization. It is not as fast. Okay, but yeah, it should work. Just wait for some time. So in the meantime, I'm just going to paste this architecture. You know, this is also done, right? We've completed the auto scaling group also. This is also done. I'm just going to copy paste this into the document. I'll put it at the end. Okay, architecture diagram will be at the end. Just refer there. AWS WordPress HA architecture diagram. This is the diagram that you will be implementing. This is the architecture that you will be implementing. Okay, and you should be able to test these two scenarios. Okay, if you configured everything properly, if you had everything, if you just followed all the 41 steps properly, you should be able to go. And once the website is up and running, you can just terminate one reader instance and browse the site. That's the test that you should kind of do. Yeah, see, it has picked it up. Pre-in service, it has started creating another instance, another EC2 instance. Let me refresh this. Yeah, see, there's one more EC2 instance which has come up. Okay, so let's do one thing. Let's get a little more adventurous. So now there are two EC2 instances running, correct? Now this is the old EC2 instance which is already running, which has an issue. Okay, that has some issues with the CPU, or it is crashed or something like that. Okay, so it has brought up another EC2 instance of the same, which is running. Now, if I go ahead and access the website, it should be even more faster. Yeah, it's still coming up. I think it's getting registered to the ALB, I believe. Let me go back to the ALB. I'll go to the target groups. Let me check that. Go to the targets. Yeah, see, it's registered to the ALB also, and it's healthy. It has turned healthy also. Now, if I just go ahead and refresh it, yeah, see, it's back to its normal performance. Okay, so now what I'm going to do is, so now that this new instance is running, I know that this instance has got an issue, right? I mean, this instance has got 2.54 has an issue. I'll go ahead and terminate that. I don't need that. Okay, rather I have another instance, another brand new instance which has come up. Okay, so let me just go ahead and terminate the other instance now. Just terminate this instance. Yeah, so that's gone. Okay, so now if I just go, whatever script that we ran, so that's gone. So it's like back. Okay, so now there's one more instance which is running, and there's only one instance which is part of the target group now, if you see. So now let me access the website. Yeah, see, I'm still able to access the website. I mean, not a single time I got a page not found, because the auto scaling group is taking care of it, and the image that we have built is taking care of it. Right, and in a while, you should see that. I mean, this anyways is going on. So it should just bring it back to the original size of desired capacity is made one. Okay. Anyways, this will fail because I've deleted that instance. Oh, no, this should pass because a new instance has come up. Correct. So that's the beauty of auto scaling groups, and that's the beauty of load balancing. That's how you build scalable applications, where you don't tie the dependency to the underlying infrastructure. So you can just copy the image location and see where it is being served from. So it is being served from CloudFront. Okay, but provided you just do these steps that I've given in the initial. So I forgot to put that, but I just later added it. I realized it and I added that steps. Yeah, so this step is very important. And these two steps are important. Okay, cool. So how's it? Is it exciting?
Yes, sir.
Sorry, who was that? Can you identify yourself?
Z003.
Z003. Okay, cool. Great. It's kind of good learning, right? I mean, so it's like you should be able to do it over the next 2 days, right? And I don't think you will get stuck, because instructions, if you follow the instructions, if you get stuck somewhere, redo those instructions. Just go line by line, And in the screenshots, just check every single setting, every single parameter, and perform those steps. Okay. Now, finally, I'm going to give you a cleanup. So the final step would be to do a cleanup. It's very, very important. Cleanup 1. First step in the cleanup is go delete the auto-scaling group. Check the auto-scaling group and delete. Delete. Yeah. So that you are stopping the auto-scaling group from adding more instances. Then select the launch configuration and delete the launch configuration. And delete the launch configuration. Okay, next go. Delete the target group. Delete the load balancer target group. Actions, delete. Okay, for that, first delete that load balancer itself. Select actions, delete the load balancer. Delete the ALB. Delete the load balancer target group. Delete the load balancer target group. So then go to EC2 instances. Delete the delete all the RPL lab reader and writer instances. Terminate all the RPL lab reader and writer EC2 instances. Okay, everything is deleted. Then go to CloudFormation. Select the CloudFormation. Sorry, CloudFront. Select the CloudFront distribution. Disable it and delete. First, you have to disable. Just disable. It will take a while to disable this. Once disabled, it will take 15 minutes to disable. Once disabled, delete it. Okay, that's done. So then what else? This is the go to S3 buckets. RDS. Oh my god, RDS is the killer. Just go select the RDS database and delete it. Actions, delete. Don't create final snapshot. Okay. Uncheck create final snapshot. Uncheck. Okay, not check. Uncheck it is. Uncheck create final snapshot and acknowledge and delete me and delete. Acknowledge and delete. Okay, that's done. Go to S3 buckets. Select the S3 bucket. Empty the S3 bucket. and then just select this first empty the S3 bucket. Okay, empty the S3 bucket. Okay, sometimes empty works, sometimes it doesn't work. Yeah, empty it and then delete the bucket. Okay. Or just delete, go inside, select all the objects, delete it, then come outside and go to the S3 bucket and select the S3 bucket, delete. Delete the bucket. Yeah. Empty both the S3 buckets. Delete them. What else are we left with? RDS is done. This is done. This is done. CloudFront is done. This is done. ALB is done. Okay, cool. I think we have covered everything. We have deleted everything. Auto scaling group, launch configuration, ALB load balancer target group, RPL lab reader and CloudFront distribution, RDS database, S3 buckets. Okay, cool. I think that's all done. So all the best. Okay, I'm going to give you this 25-pager document. So please go into your breakout rooms and start the assignment. Just follow the steps. Okay, I've ensured that I've made it quite exhaustive. Oh, sorry, is this 25th? Not 25th November. Sorry, I gave the wrong file. Just giving you the right one. Yeah, AWS RPL project 1. That's the document. It's a 14 MB file. So just download it. Maybe Sai Krishna, you can upload it in the Google Drive also and give the links to everybody.
Yeah, I will.
Yeah, sorry, I think your voice was breaking. I don't know, probably it's an issue at my end.
Okay, yeah, we could hear you properly now.
Okay. My voice was audible, right? All the while?
Yeah,
it was not like breaking in the middle. Okay.
Yeah, it was good.
Okay, I was just for now, you don't need to follow the recording. You can just follow the document that I've given you. I've given every single step in the document. You just need to pay attention to every step, follow whatever I've given in the document to the project, and I think you should be done by tomorrow. Okay, so whoever was able to, see, it shouldn't take more than 3 to 4 hours to complete it. I would say, if you start now, if you're not able to complete it by lunchtime, don't worry, resume it post lunch, complete it by evening. By evening, you should be able to clean it up. Don't leave it running overnight. Okay, don't think that you can come back tomorrow and resume the project, because you'll be charged. Okay, that will be an unnecessary charge, because RDS, even though you're using a standby, which is a T2.micro, but still there will be some minimal charges. If you want, you can avoid that completely. If you don't want to create a multi-AZ RDS, go with a plain standalone RDS, like what we did in the other lab, the RDS lab. Okay, you can just go with a plain, simple standalone lab. So for that, instead of choosing production, choose the free tier. It's totally up to you. But if you just choose the production, you'll be able to see how RDS also works in a multi-AZ mode, but there'll be very minimal charges. Okay, so if you're okay with that, go ahead. Otherwise, if you're doing it in a block of like 3 to 4 hours time, It's absolutely fine. You just finish it, deprovision everything, and then don't carry it over to the next day. Especially the auto scaling group and all of that, don't carry it over to the next day. Just keep it, close it today itself. It's easy. You can just complete. I'm sure you'll be able to complete it in 3 hours, 3 to 4 hours. Okay. All right. So you got the document, correct? You're able to download the documents. So let's see. Raise your hands and how many of you were able to are ready for this challenge to complete it in about 4 hours time. Start now. By evening, you should be able to complete it. Okay, nice. Come on, more. I want more hands to be raised. Wow, excellent. I think 70% of the class have raised your hands. That's awesome. Cool. Okay, great. Okay, so then I'll leave you, for now, and then I'll see you all tomorrow. Complete this lab today. If you're still not able to complete it, don't worry. You terminate all the instances. Come back tomorrow. So tomorrow, we will meet at again morning 9 o'clock, and I'm going to kind of take a few questions and then let you go into your breakout rooms and continue your project. Okay, so these 2 days are for project primarily. Okay, if you have completed it today, don't worry, you can still do one more time tomorrow so that it will give you a good hands-on. Okay, all right. Thanks all. Thanks for joining today's session. I'll see you all tomorrow. So you can go into your breakout rooms now. Thanks, Sai Krishna. Please and let them all go into the breakout rooms. And thanks, mentors. I'll see you all tomorrow. Bye now.